Welcome to another RDWorks Learning Lab. In today's session I was going to try and answer a couple of questions. One of them was about head position, the starting point for the head, which as far as I'm aware you can change within the RDWorks program. The second issue was to try and capture a factory default file off of this machine for another poor guy who had got his machine in a bit of a tangle. In trying to capture that default file, I've basically screwed up my machine and it no longer works. Now, as far as the head position question is concerned, to be honest, I think 99% of the time I've been using this machine, I've always used it in the current position. There is another position on there which I have used called absolute, and absolute works wonderfully well. So if I want to set up a specific coordinate on this machine, it's very difficult to do it from the keyboard. But with the absolute program, if you just draw a program starting at, say, your start position, say 100, 100, then if you drop that program into the machine and just literally run it with a frame, it will stop the head at 100, 100, and you can then press the origin button. Job done. You can then swap it over for your running program that you want and run that program from 100, 100. So without the aid of the machine at this very moment in time, I'm going to have to look at the manual and just establish, if I can, how the other options should work on this machine. It's an addition to the datums and 0 points that exist on this machine. But in this particular instance, it's all to do with controlling the position of the head relative to somewhere on the table, but you do that from this RDWorks program. I just want to point out that down at this bottom left hand corner, we've got a little green square. There's nothing on the screen at the moment. I'm now going to put a square on here. I'm going to hold down my control key and we're going to generate a square. You'll notice that the little green square has now jumped to the top left hand corner of my object. I'm just going to remind you that if we go to config system settings, the reason why the green square is there is because I've defined my laser head to be in that position. So it's not just a green square, it's a definition of where the laser head will be. And in fact, that's the point from which the programs for cutting this particular shape will be written. They won't be written from machine 00, they'll be written from this point here. I can feel you getting a bit uncomfortable, some of you guys, when I talk about writing programs. When we move down to the bottom right here, we can see that there's a button called Save to U file. When you press that button, all sorts of magical things go in the background and your pictures here get converted into instructions that feed the machine with information that it can understand and digest. First of all, we will set this to a nice usable dimension by going up here to our padlock and making sure the padlock is closed, and then we'll set this to 100mm square, because 100mm is a nice easy number to remember. Ignore the pink handle on there, and I call it a handle because it's a drawing handle, because it isn't there really. Look, it's disappeared. But then again, the other handle that's on here is not visible either. That's in the middle of this object. How do we know that? Well, look, if we look up here beside the padlock, there's a little black object right in the middle. That's an object handle, and it's used for referencing the position of this object on the grid. For example, if I want to position this rectangle at position, put a marquee around it, and then I can go up to the X and Y positions, and I could define that position as 100 by 100. And if we check the coordinates down the side here, we'll find that 100 by 100 is where it's moved to. But there's no handle there that you can see. But there is actually a positional handle, a reference handle, that is moving this object around. Now, for the purpose of this exercise and making it so much clearer, what I'm going to do is double click on this little object, and we're going to put our handle, instead of in the middle where it is at the moment, we're going to move it to the top left. So now we've actually got a positional handle for this object at the same place as the program writing handle. The program writing 0, should I say, because it isn't really a handle, it's just a datum point. I just want you to remember, look, we set this position of this center handle up at 100. When I look at it again, this object, you watch what happens to X and Y. They're 50-50. That's because nothing has changed on the drawing except the position of the location handle itself, the reference object handle. And it's now moved to this corner here, which is no longer 100, but it's at 50-50. So my object is now moved around by its corner point, not by its center point. That is an important thing that you should remember. Now, I've been using this program for over a year now, and I have never found the need to move that to this corner. There is a danger of having it in the middle with what's about to follow, because if it is in the middle and I finish up moving the center point to 0, like that, look what's happened. Some of the object is outside the work area and the machine won't recognize it. It'll throw a hissy fit. Anyway, let me just reset this again to a correct dimension where I wanted it, which was 50-50, remember now. If you just follow me down to the bottom right hand corner here, we find that we get a little box which has got position in it. And if we open it up, we'll find that there are not just one, but there are actually 4 positions in here. I very much doubt whether many of people will have actually been down there and looked at these, because you've never had a problem with your machine. It's always been set to current position. Now, what does that position mean? Well, that is actually the position of this green square, the starting point for your program. Okay, now I've actually just put a very simple program inside the square just to show you the sort of basic instructions that the machine will work to. It will help to define the difference between these 4 positional situations that we're going to describe. The first one is this current position. I'm sure you'll all be familiar with the fact that if you move the head around with the arrow keys, you can stop at a given position and press the origin button, and that is where your program will start. So that means the program could start at any point on the table. How do you write a program for that? Well, the answer is you don't. What you do, you write a standard program, and the standard program for this square is written from the datum point of the square itself. Let's just look at how this and all the other squares that I'm going to be talking about will be written. First of all, let's ignore the fact that it says go to origin. It says beam on, so it turns the beam on, and then it's told to move down from position 0, because remember this is position 0 in X, and it's got to go minus 100 millimeters in Y. Why minus 100 millimeters? Well, according to the Cartesian coordinate system that this machine works on, if you remember your graphical days back at school, down at the bottom left hand corner would be 0, 0. As you go up this y-axis, it's plus, and as you go right along this axis, the x-axis, it's plus. At this top left hand corner, our y-axis 0, 0 is there. So when we start coming down below 0, this is a minus coordinate for the machine. Even though it says plus and getting bigger and bigger down this way, it's actually a minus coordinate as far as the machine is concerned from its 0, 0. So anything going downwards is minus. So that explains why we're going to go from position 0 in X, we want to move down to minus 100 in Y. And then we want to stay at minus 100 in Y, and we want to move X across to plus 100. And then we want to keep X at plus 100, and we want Y to go up to 0. And then we want them both to go back to 0, 0. And then we turn the beam off. And that's how we're going to cut that square. Those are the very basic, simple instructions for cutting a square. The same will apply to every one of the following, and I'm not going to step through all the others. But what we are going to talk about is this first line here. Now, in this particular instance, we've said that the origin, we could put down the origin anywhere on the table. It could have any coordinate dimensions we want. Let's just assume that the coordinate position that we want is where we have defined it at the moment, which is 50, 50. Now the other thing I must point out to you is that the origin is stored in machine memory somewhere, and so the last origin that you store is always the one that's in the machine. So what the program does, it looks into its memory for origin because it sees it's a current position and it needs to go to the origin, and it says, so the origin is 50 minus 50. I must adjust the program accordingly. So what it does, it rewrites this program temporarily. It doesn't mess around with the original program, but it just rewrites a temporary program which looks like this, which basically says, relative to the coordinates 0, 0, I need to move down to minus 150 in y, and I've got to be at 50 in x. So what it does, it converts these temporary coordinates here for the object into real world coordinates relative to 0, 0 by adding on the current position in memory for the origin. Okay, now we're down at the bottom right here again, and this time we're going to look down the list and we're going to choose machine 0. Here we are with our program set up to run from machine 0, 0. We could be sitting right over in the middle of the work table here with our head. We press the start button and the first instruction that the head gets is go to machine 0, 0, which it does. And of course it is 0, 0. And what does it do from there? It says, okay, I've got a program now which coincides with this point, because technically what it's done is lifted this point and driven it to 0, 0, which is exactly the same as us picking up this and moving it to that position. Or the machine doesn't have to make any adjustment or changes to the program to run it from 0, 0. Back to the right hand corner again, and this time we're going to look at something called anchor point. And here we've got the program written for anchor point. It's exactly the same program that we've got written for the other two. It's just that the starting instruction for each one of these is slightly different. With origin, the program was offset by an amount that was stored in machine memory. With machine 0, 0, there was no storage of data anywhere. It was just sent to run the program from a known machine 0, 0 position. When we get to anchor point, there's nothing stored in the machine at all. What happens is you will drive the head around to a point where you want it to be. And this time, when you press the origin button, the origin will be stored in the program itself. So when it runs the program, it makes all the same adjustments that it did when it was using an external origin, but this time, instead of looking outside the program, it looks inside the program for the anchor points that you have set by pressing the origin button. What that means is that you can store this program away on your machine. Weeks, months, 10 programs later, it will still run from exactly the same position because the coordinates are stored inside the program. We're back to the right hand corner, and at last we arrive at the final option, which is absolute coordinates. It's very straightforward, having dealt with the others. The important thing to remember here is you do not define the coordinates in the machine. You define those absolute coordinates on the drawing itself. When it writes the program, it will write that one directly. So whenever you run that program, it will automatically go to coordinates 50, 50 to start the program. You will not be able to change it. There's no editing on the machine for this particular situation. There is editing on the machine for the anchor point, because you can drive the machine around to a new position, and when you press the origin button, it will send a new anchor point to your program. There is no adjusting the 0, 0 on the machine, so there's no editing on the machine for machine 0. But of course, there's always editing on the machine for the current position. You can move that to where you want. Well, I do hope that breaking it down into these fairly simple steps has given you a clear understanding how each one of these works. Something I've forgotten to tell you. This is an old version. If we take a look up the top here, we can see this is issue 11. This is a good, stable, but fairly old version of RDWorks. The latest issue is issue 18, which can be obtained from the Reader website. One of the problems with this particular version of the software is the scroll zooming of the mouse. Now, I can zoom up as large as I like, but if I zoom out and carry on zooming out, it will disappear to absolutely nothing and the program crashes. So just be careful when you're rolling and scrolling with your mouse. Well, here we are a day later. I've managed to get my machine fixed after all. It was not as serious a problem as I thought it was going to be, and there is a whole session that follows this one on how I managed to fix the machine. So that whole saga is recorded completely separately. Now, 2 of the 4 head positions that are available in RDWorks I have not tested. So I've done my assumptions of how they work, because they're very simple basically. If something says it starts from machine 00, this is where it starts from. So, you know, the only questionable one as far as I'm concerned is anchor point. And I believe that the anchor point is the one where the program 0 is stored within the program itself, so that whenever you come back and run the program, it will start from the position that you set within the program, i.e. even if it's 00 now, it'll jump to the last anchor point that you left in that program. And provided you don't take it out of the machine, that program will hold the 00 for the program. And that's the whole point of something called an anchor point. Let's go and see whether or not our assumptions are correct. This is very much an egg on face job, because I'm going to demonstrate to you now the 4 positions that I was talking about. Now, the first position I was going to talk about was the absolute 0 position. As far as I could work out from the manual, absolute position meant that the program would run from machine 00. Here's my program that I've written in here. Let's just see what happens when I press the run button. It started off at 174, didn't go anywhere near 00. And in fact, let's just move the datum to some other random number. Let's go to about 130, 125, 128, there we go. And we'll run the same program again. I'll press the origin button. And it finishes back at 128. So that's not working. Let's select the anchor. The anchor is not a fixed position. The anchor is, let's start it off where it was previously. Specify the origin as that, 128. Run the program. Now, as far as I was concerned, the anchor position was anchored with that program. So let's change the X for 200 or something like that, and it's now 194. And it's still 194. Now let's leave that program. Remember that number, 194. And we'll go to our current program. And the current program says wherever I put the coordinate, and let's make it something like 100 by 100. Something like that, 100 by 100. Origin. Run the program. Okay, 100 by 100. Let's go back to anchor. So we've got our anchor program back in here, and let's just see what happens. It's picked up the current origin. It hasn't stayed with its old origin. So anchor hasn't worked how the book indicated it would work. Absolute 0 hasn't worked how it was described. Current is obviously working as we expect, because we can move the current position around. But now we're going to try the absolute setting, and to make life easy here, because my memory is not quite what it used to be, I made the start coordinates for this program to be 100 by 100. So what I've done at the moment is to set this coordinate to some strange number like 150 in X and 0 in Y. The first thing I hope it's going to do when I press this button is go to position 100, 100 and draw a square 100, 100. So let's give it a try. And sure enough, it must have started from 100, 100 because it's finished up at 100, 100. Well, hey, we've got something that actually works apart from current. Now I've generated these programs in issue 18 of RDWorks. They're not known for their most bug-free software, so it is possible that there is a bug in this particular version that I'm using. I've now done exactly the same set of head positions, but this time I've saved the information from issue 11 of RDWorks. So the first one that we've got in is current. Just for convenience and easy to remember, we'll set it at about 150, 150. There we go. Origin. Run. $150, $150. And if I change that to say 100 and run it again, it comes back to where it starts. So the current position works fine. Let's try 0. Now 0, as far as I'm concerned, should go right to the top left hand corner of the machine and run the program from 0, 0. And it doesn't, it still runs from the original 0. So 0 doesn't appear to work on that version either. So what is the point of having an absolute 0 head position if it doesn't start from where you expect it to start from? Right, let's try absolute. Sorry, you won't be aware of this, but I drew my absolute drawing and programmed it from coordinates 100, 100. Well, that does seem to work because it started from and finished at 100, 100. Now we'll try anchor, and if we press the origin at that point, I should anchor that at 100, 100. And sure enough it has. Let's go to the current program where we can drive the datum around to something like 50-50, say. 50-50 more or less. Origin. Run the program from there. And it's gone back to 50-50. We'll load in our anchor program. And the question is, will it run from 50-50 or will it run from the previous value? So it runs from 50-50. So what use is that? It runs the program from the origin, which is exactly the same as the current situation. So there is no point in having an anchor, and there is no point in having a 0. The only one that seems to work is the absolute coordinates, which were 100, 100, and if we go back to that, absolute, enter, and that should jump to 100, 100. Which it does. But at the moment I don't think that that has set any sort of origin. It's just running from that position without the origin. But if I press the origin at that point, I've now fixed the origin at 100, 100. And if I go to my current program and run that from there, that runs from 100, 100. I'm puzzled about all these options because they don't work as the manual describes that they should work. Okay, well here we are in RDWorks ready to interfere with the program on the machine. So we go up to the user tab and we've got all these options down here. Now I shall just read what's in there at the moment to get things active, because only when I've got read can I access the write button. And in other, we've got this thing here called return position. Now if I take a look here at return position, now I've got a little window which gives me three options. The current option that I've got is something called absolute origin. Now the Chinese seem to have a problem with this word absolute, because to me, very simple plain English terms, absolute origin would mean the machine datum, i.e. the absolute origin for the machine. No, they think that absolute origin means the absolute origin of the program itself, and that's how it's currently set at the moment. The machine goes to 0, 0 for the program, it runs on a little bit and then comes back and finds the absolute origin for the program. Let's just change that to origin, and we'll write that back, and we'll go and have a look, see what effect it has on the machine. Okay, well now we've set origin, and we'll run the program again and see what effect that has. Okay, so now at the end of the program the head runs completely out of the way back to what I would define as the absolute origin, but the Chinese decide to call that the origin. Run that again and you'll see what happens. Start of the program, and the head disappears off to 0, 0. Now that's very convenient sometimes if you've got a big piece of work on the machine and you want to clear it out the way, clear the head out the way. So it has got a function. Right, well let's come back to here, and we will now see if we can change this return position, and it clearly says return position. We'll change that return position for no return or not return, and we'll write that back to the machine. So we're starting off from 0, 0. We shall run the program and we shall see what effect not return has. Well, the answer is not a lot. If you look very closely, right at the end of the program, you'll see that it overshoots by that 5mm, i.e. it comes across, goes here, but it doesn't go back to find the origin. Did you see it kick to start with? So the start of the program, it goes back to find the beginning of the program, and then when it finishes the program it just stops at the end of that small over travel. What use is that? Has it got any function at all? If you think it has, perhaps you could let me know. So I shall continue using absolute origin. Why? Just seems the most useful one, unless you've got big work that you want to take on and off the machine regularly. So we started off this session trying to do an in-depth analysis of how these various head positions would work. That was actually a bit of a waste of time really, wasn't it? Because once we moved on to the machine, we found that the manual did not describe how this machine works at all. You may be interested in knowing that I have developed a complete index of all the videos that I've ever produced. Here's an example of how it starts. Bullet points enable you to have a quick survey as to the content of each video. Now this PDF index is about 30 pages long, and it is available at the website below. Now you'll have to join, you'll have to give them your inside leg length and things like that just for security reasons, but it's worth going along because I'm sure you'll meet other people just like yourself who have suffered at the hands of a Chinese laser cutting machine.